Hello, I'm Dan Miller, and I'm going to talk to you about some of the latest findings in climate science. We'll also talk a little bit about some of the policies we can put in place to address climate change and also talk about climate change messaging. But let's get right to some of the latest science. NASA climate scientist Jim Hansen published a paper last year that showed that extremely hot summers, which are technically defined as average summer temperatures in a particular place that are 3 sigma above the baseline period. Another way of thinking about it, summer so hot that would only occur normally about once every 500 years. Well, those extremely hot summers in the last decade were happening about every 10 years. That's a 5,000% increase. Now, what's interesting about this is that this study is not based on climate models, and it's not even a prediction. It's based on actual measured temperature data from the last 60 years. In other words, this increase in extremely hot summers has already occurred. Now, because the increase was so dramatic, we can tell that some of the extreme heat waves that we've experienced recently, such as the 2003 European heat wave that killed 70,000 people, the Russian heat wave that triggered very high food prices recently and helped trigger the Arab Spring, and also the recent heat waves in Texas and in the Midwest in the United States, we can tell that these heat waves were actually caused by global warming, because the probability that they were caused by global warming is much greater than the probability that they were caused by natural variation. You're probably aware that the Arctic sea ice melted a lot in the last summer. Well, we very often look at the area of Arctic sea ice because it's easy to measure. You take a satellite picture and you can see the area. But scientists also measure the volume of the Arctic sea ice. And if you plot out what the minimum volume was each year at the end of the melt season, you get this graph. And you can see while it varies back and forth a bit, it's following an exponential curve downward. And if you plot that curve all the way to zero, you see it hits zero in 2015. Now, that doesn't mean that the Arctic will be completely free of ice in 2015, but there's a good chance it'll be quite close to that. Now, that would only be for a short time, maybe only a day or two that it would be ice-free in 2015. But in the following years, that will increase to a couple of weeks, eventually a month or two. Now, why is that important? Well, the Arctic the Arctic sea ice reflects sunlight in the summertime and helps cool the earth. It also has an impact on the jet stream. In fact, the fact that Arctic sea ice has already melted about 40% has already changed the way the jet stream works, slowed it down a little bit, and made it wavier. And that has helped contribute to some of the crazy weather that we've been seeing in the United States as well as around the world. So once the Arctic is ice-free, later this decade, it could have a serious impact on our daily weather. So climate change is not just something that happens in 2100. It's happening right now and might even dramatically change in just this decade. Moving on, in 2009, scientists at MIT published a study that looked at what were the chances that we would reach certain temperatures by the end of the century. So they did this in a probabilistic way. They said, these are the different probabilities of reaching these temperatures. They did it under different scenarios. And this chart shows the no policy. Another way of putting that is the business as usual approach to burning fossil fuels. In other words, continuing to burn them at similar rates to what we're doing now. Well, the first thing to note is that most scientists and most politicians agree we should not cross the 2-degree temperature increase line. 2 degrees is about 3.6 degrees Fahrenheit. Because past this point, we would be going into the realm of dangerous climate change. Actually, even 2 degrees will be pretty bad. But going beyond it is something we really don't want to do. But the scientists at MIT said, based on the path we're on, there's a 95% chance that we're going to hit 3.5 degrees by the end of the century, which is 6.3 degrees Fahrenheit. And there's a 50% chance that we're going to reach 5 degrees Celsius or 9 degrees Fahrenheit And you'll also notice under these scenarios, we cross the 2-degree line in the 2040 to 2060 range. So what does 5 degrees Celsius really mean? Well, climate scientist Kevin Anderson from the Tyndall Center in the UK talked about what he felt a 4 degrees Celsius or 7 degrees Fahrenheit increase in temperature would mean for us. First of all, he said that it would be incompatible with an organized global community, that it would be likely to be beyond adaptation. In other words, you're not going to just turn off the air conditioner and build higher seawalls. That won't be good enough. It would be devastating to the majority of ecosystems and would have a high probability of not being stable. In other words, once the temperature got that warm, it would trigger releases of more carbon dioxide and methane through melting of the permafrost and methane from the oceans and other things like that, that would drive temperatures even higher. So he said, therefore, we must avoid that at all costs. There's no economic argument you can make, there's no discount rate you could use that would justify continuing on a path that would lead us to 4 degrees Celsius. But we can do something about it. The folks who did the MIT temperature study showed these 2 roulette wheels of probability distributions. On the left, it shows the business as usual, no policy case. And you see that almost the entire wheel is temperature between 3 and 7 degrees. But on the right side is a wheel that shows if we do implement policies to limit carbon emissions, that we have a much better chance of staying in the 2-degree range. So what can we do to reduce carbon emissions? Well, one of the best ways to limit carbon emissions is to put a price on carbon. And a good way of doing that is a policy called the Clean Energy Credit. With the Clean Energy Credit, you put an increasing fee on CO2 at the wellhead, mine, or port of entry. So fossil fuel companies would pay a fee based on the CO2 content of the fuel as it's extracted from the ground or as it comes into port. The fee would start off very small, but would grow every year. So we would have a long-term understanding of what the price of carbon will be in the future, so businesses can plan for it. An interesting aspect of the Clean Energy Credit is you take 100% of the money collected, every penny, and you return it to every legal resident on a per capita or equal basis. So everyone gets the same check every month. Because of the 80-20 rule, which says about 80% of the emissions are generated by about 20% of the population, most people would make more money on the credit than they would pay in higher fuel and product costs. So it would have strong public support. One other thing you do when you implement that policy is you put a border duty on products coming from other countries that don't have their own fee on CO2. This would protect our own industries and strongly encourage the other countries to implement their own fee on CO2, which would help them reduce their emissions. And that's very important because if the United States alone were to reduce our emissions, but everyone else continued accelerating their emissions, we would not be able to keep the temperature of the Earth down, and that would affect everyone. Now, putting a price on carbon would have some other good effects besides reducing emissions. First of all, it would drive innovation and investment in renewable energy and energy efficiency and would create millions of jobs. It would trigger an economic boom that, as I say, would put the internet revolution to shame. It would also, of course, improve energy security and eliminate the need to fight wars over oil and clean up pollution as well. Now, climate change is a pretty scary thing, and a lot of people don't like to talk about it, including environmental groups and climate scientists. They don't like talking about how bad it could get. And as we just discussed here, it could get pretty bad. But how is it possible to avoid those bad outcomes if we don't talk about them? So fear is actually a very powerful, motivating emotion. As Ben Sherwood said, without a doubt, fear is the most ancient, efficient, and effective security system in the world. Casey Golden said about climate change that climate change is not a message. It's an objective reality and an urgent crisis. That's why we must talk about it. So when talking about climate change, I think it's important to let everyone know that it's something that we caused and therefore we're responsible for doing something about. Also let them know that we can do something about it. And always talk about climate. Don't hide the climate message behind other issues such as water pollution or oil spills and things like that. Those are important, but protecting the planet is the number one priority. I'll end with this picture of Florida under 16 feet or 5 meters of sea level rise. This is something that could certainly happen as soon as later this century, and certainly by next century if we continue on the path we're on. As Tom Friedman said, you may not be interested in climate change, but climate change is interested in you. If you'd like further information on climate change or to read a little bit more about my background, you can visit my website at climateplace.org. Thanks for listening.